How far are you now? No, I want learn. Ready? So the first two columns can go? Okay. Image going to look a bit darker, but they'll be able to see the board more because at the moment they have the two bright spots on the screen. But those students who are on YouTube, they don't have that. Understand? The students on TikTok, they have that too. So we're going to do the changing over of the light. So I'm going to put on the daylight, but we have to turn the bulb away. We want to let it stop in. How is it this? Right, so that's nice. Over here, right? Can you see? Are you at the end? Are you at the end? Okay, so here I am. Saying a good evening to everyone, and I hope that you enjoyed, and if not, enjoy alone, that you had restful holidays, and you will not have any more holidays to rest until December, which is, of course, not very far away, and considering that November has only 30 days, so we are just 1 day short. Yes. Yes, November is 1 day short. So good evening again, everyone. We'll give the students some more time to get on before I give you my official good evening and welcome. I'm going to be using the daylight, so I'm going to do what it takes to get that, not that, yeah, that's that patch, and the other one is a larger one out. So in order to do that, we generally use just the daylight alone, and it's not so bad. There you go. Right, so we have this spot right there that I'm fighting against all the time. Yes, that spot. Because it shines back. It shines back on the paper. I'm going to use that darker paper and see if we can get it to function a little better so that we have the entire use of the board. We have one right here that is not so bad. And of course, when my computer screen comes on, we'll have another one, so I have to turn away my screen. For the most part, the board is visible. I'm using a black marker for the most part, that's what I use. So we should be able to see what's going on. We did not finish. Somebody's asking what topic today. Students, I do not hop, skip, and jump. So we are continuing with the transposition of formulae. So the instruction is still on transposition. Yeah, so what we did the introductory portion of the topic where we dealt with the finer details of transposition, and we mentioned some misconceptions and attempted to clear up some misconceptions. We'll continue, and of course I will continue to mention the misconceptions that students have, and I will continue to clear up those misconceptions. Right. Now, since we are through with the introductory portion of it, then you know what we move on to next is the exercise. Because we always do exercises in class. So we have the class exercise has 20 problems, and we will not waste any time to take a look at the first 5. So we're going to be taking a look at the first 5. I want my old book. I'm not seeing it at the moment. This is the book that I'm using now, but that's not your book. There it is. All right, so hopefully we can get onto the same page. Transposition of formulae. You know better than I what page we'll be using, because quite likely you have the new instructional manual. But I have the old instructional manual. So you are more aware. Somebody with the new instructional manual can tell the page that I'll be on. We are going to be doing the exercise, and I'm going to put the first set of problems on the board. Okay, let's go. Number 1, C is equal to pi d. For d, PV is equal to C for V. PV is equal to C. I think it's common C for V. And number 3 is your favorite. V squared is equal to 2GH for H. I'll put number 3 right there. Number 3 is your favorite. V squared is equal to 2GH, making H the subject of the formula. And we have a tendency to put 5 of them on the board each time. So number 4 will go there. I think it's a little bit too high. Number 4 goes there. Maybe it's a little bit too wide. P is equal to Q over R for R. P is equal to Q over R for R. And number 5 will be T is equal to U over A for U. T is equal to U over A for U. So we have the proposed subject. Well, we have the formula there, and we have the proposed subject also. And we are ready to transpose. And it's at this point that I say a big welcome to everyone. Yes, a big welcome to everyone. And thank you for gracing me with your presence. Thank you also for inviting others, you know, and students generally participate. I'm thanking you in advance for your participation. And of course, a big welcome to all. So, welcome to everyone. Welcome to the big timers, and welcome to the newcomers. And for also some of the individuals who just saw it pop up on TikTok and decide to just get in. So, to you, a big thank you and also welcome. Good evening to everyone, and let us begin. We have that formula, C is equal to pi d, and we will make, what do you imagine that we are going to make the subject of the formula? Even without saying, you should be able to tell what the proposed subject is. C is equal to pi d. First of all, we will not make C the subject of the formula because it is already the subject of the formula. So if C is the proposed subject, we do not have a problem. D, well, say pi. Of course, it could be asked, make pi the subject of the formula. And you can consider how much sense that would make. Maybe you think it wouldn't make any sense. But of course, it can make sense that pi is the subject of the formula. In experiments where pi, of course, is not a variable, it's a constant. Pi is a constant value. You might want to estimate the value of pi. And so you use a string to determine the radius of the circle. You know the diameter of the circle, and then you divide that. And then you do that quite a few times. And then, of course, maybe you would want to draw a graph, and then the gradient would be pi. So that would be good for an experimental purpose. But in terms of finding a value, you would not naturally make pi the subject of the formula. It's only in an experiment that you would do that. So the most natural subject of that formula is D. And if we're making D the subject of the formula, the only thing that is getting in our way right there is pi. Pi is getting in our way. Pi is related to the proposed subject. How is pi related to the proposed subject? The proposed subject is D. How is pi related to that proposed subject? As you can see, we have pi d. Pi d means pi times d. So pi is related to the proposed subject by multiplication. They are in a multiplication relationship. So because it is multiplied by pi, we will eliminate pi by division. We have to do the reverse or the inverse operation. We will eliminate pi by doing the inverse operation. It is related by multiplication. We determine that. Next thing that we do is what? We eliminate it by division. And what will happen is that we will divide by pi on the other side also. But we are not going to show that intermediate step. No, we are not going to show that. Yes, we are not going to show that intermediate step. So this is what we do. We divide by pi here, and the pi will be eliminated. And we balance the equation by dividing by pi also. So what we will have is c over pi when we divide by pi on the left-hand side. When we divide by pi on the right-hand side, it will be eliminated, and we have d. So d is equal to c over pi. We divide both sides by pi, students. We will eliminate pi by division, but we cannot divide by pi on the right-hand side only. We have to divide both sides by pi. So, dividing both sides by pi, pi will be eliminated from the right-hand side, and on the left-hand side, we'll have c over pi. We cannot leave the formula, well, we shouldn't, with the proposed subject on the right-hand side. So, for more reasons than one, we end up with the proposed subject on the left-hand side. What are the reasons? Well, I can give you more than one. One is that the equal sign is a one-sided sign. So it is not good to say that this is equal to the proposed subject, but that the proposed subject is equal to that. So the equal sign is not a two-sided sign. It is a one-sided sign. And also, although it is singled out here, it is not the subject of the formula unless it is on the left-hand side. So we have more than one reasons there. Now let us go to the next one. PV is equal to C, and what is the proposed subject in that case? The proposed subject is V. The proposed subject here is V. So we need to make V the subject of the formula. V is cumbered by P on the left-hand side. It's accompanied by P. How so? The proposed subject, which is V, let me make sure. Yes, the proposed subject, which is V, is hampered by P. So we need to eliminate this P. And of course, we can see that P is related to V by multiplication. That's what PV means. P times V or V times P. Multiplication is commutative. The order does not matter. They are in a multiplication relationship. We will therefore eliminate this P by dividing by P. But we cannot divide an equation on one side only. We have to balance the equation by dividing by P on the right-hand side also. So we're going to divide both sides by P. When we divide the left-hand side by P, the P is going to be eliminated. And on the right-hand side, we have C over P. And that's all there is to it. Maybe I should write it a little bit down somewhere, since this is done in one step. So V is equal to C over P. V squared is equal to 2GH. That's the next one. V squared is equal to 2GH. And of course, if we eliminate the thought of an experiment, what would make sense as the subject of this formula? Do not imagine that this is just an alphabet soup. Or what? A pack of alphabet biscuits. This is a formula. V squared is equal to 2GH, where V stands for velocity, H stands for height, and G is the acceleration due to gravity. G is the acceleration due to gravity, which is a constant value. So it makes sense we find the value of H. So H in this case is the proposed subject. So H is our proposed subject, and it's accompanied by 2G. And H is being multiplied by 2G. We will eliminate the 2G by dividing by 2G. And so we need to balance the equation by dividing by 2G on the other side also. So when we divide both sides by 2G, we'll have V squared over 2G right there. And on this side, the 2G will be eliminated. When we divide this side by 2G, the 2G will be eliminated from here. And on that side, we have V squared over 2G, because we are dividing both sides by 2G. At the end of it, we have what? Make H the subject of the formula. H is equal to V squared over 2G. And what's the name of this? Transposition of formulae. We are transposing a formula in each case. And the transposition of formula is one of the greatest topics in mathematics in general. So it's not just for algebra, it's for calculus, it's for measurements, it's for it is for functions, it's for everything. Why? Because transposition of formula contains the principles that we use to solve an equation. And so I will not teach you how to solve an equation. We will apply the principles that we learn in transposition of formula in solving equations. So quite likely, by the end of this lesson, we'll move over to the solution of equations, and we're just going to apply the same principles. The solution of equations, some students might find it a little bit simpler because the equation will contain one unknown. And we do not say one variable, but one unknown. Let's continue. Number 4. We are making, I think it's R the subject of that formula. Yes, it is. We are making R the subject of that formula. I'm going to rewrite that. P is equal to Q over R. And we are making R the subject of the formula. And some students will go in a spin to make R the subject of the formula. Yes, some students will go in a spin just to make R the subject of the formula. Reason being, it is in the denominator right here. And we do not have another fraction on the left-hand side. And all of that goes haywire. Unnecessarily. Yes, unnecessarily. Now, students, there is no rule that says that you cannot eliminate the proposed subject from one side. Go ahead and eliminate the proposed subject from the left-hand side. Go from the right hand side. Go straight ahead and eliminate the proposed subject. Right there, we are dividing by the proposed subject. The proposed subject is R, and we are dividing the right hand side by R. Because we are dividing by R, we can eliminate this R by multiplying both sides by R. Well, we're going to eliminate by multiplying by R. So eliminate the R from here. We are dividing by R, multiply by R, multiplied by R. So on the right hand side, when we multiply by R, we are going to have Q alone. We have eliminated the R by multiplication. On the left hand side, we will have PR. And what do we do next? Since we have P accompanying R by multiplication, we will divide both sides by P. So the P will be eliminated from the left hand side. On the right hand side, we have Q over P. And that's all there is to it. I could write number 5 a little bit higher, yes. Maybe number 6 will not fit in, but let's see if it is flat. No, it will not fit in. So let's continue. T is equal to U over A. I think it is for U. For U, yes. T is equal to U over A, and that is for U. What do we do? In attempting to make U the subject of the formula, we have to eliminate this A that we are dividing by. Since we are dividing by A, we have to do the opposite of division, which is multiplication. We therefore need to multiply this side by A in order to eliminate the A from this side. And of course, we will balance the equation by multiplying by A on that side. So we will have what? AT is equal to U. And then finish up by saying that U is equal to AT. All right, so that's that for your first 5. The next 5 will be a little bit challenging, we imagine. But let's go straight ahead. Some of them, I might attempt to do them twice. Right, so there we have the first 5. We're going to put another 5 up there in a minute. All right, so your next 5. Good night. So I'm looking at the screen. So we'll have number 6 to 10. Nice. Number 6. A is equal to 0.64 over B. Maybe 7 here. we go. We have another 5. Lovely. So let us go straight ahead. Let us go straight ahead and transpose these 5. They're a little bit more challenging than the others, but we have not got into the real meat of the matter as yet. So, of course, we need to put number 10 up here again because we're going to do 2 takes on it. P is equal to Q over 5 plus 17. P is equal to Q over 5 plus 17. Yay! Fine. What do we say now? Be not afraid of solving a problem by analogy. I think that number, let me see, A is equal to 1.64 over, yes, I think that number 4 is analogous to this one. So let me just remind you of number 4 over here. P is equal to Q over R. PR is equal to Q. R is equal to Q over P. Right. I think that number 6 is analogous to number 4. Now let us go back to number 4. Let us revisit number 4. What do we know about number 4? The proposed subject is in the denominator right here. So we have the proposed subject in the denominator. What did we do? We eliminated the proposed subject from the right-hand side because there's no law in mathematics that says that we cannot eliminate the proposed subject. We can eliminate the proposed subject. If it is undesirable where it is at on this right-hand side, then of course we can eliminate it and cause it to be in a more comfortable or favorable position on the left-hand side. In mathematics and in life, you need to take steps that will cause you to be able to manage the next one. And that is what we have done here. So we have the proposed subject in the denominator. What did we do? We eliminated the proposed subject by multiplication. And after eliminating it by multiplication, it has an encounter with P, meaning that it is multiplied by P in this particular case. So we will eliminate the P by division, and that is what we have done. So we divided both sides by, and notice that this is the same situation. Do not afraid to solve a problem by analogy. Use the process of solving a similar problem in order to do this one. So we are dividing by B here. Of course, B is our proposed subject. We know that A is the subject at the moment. So it could not be our proposed subject. We would not have a problem to solve. Also, 0.64 would not make a lot of sense as a proposed subject. So the proposed subject is really B. So B is the proposed subject. And of course, look at this and look at this. The situation is the same. We will eliminate B by multiplication. So we'll have AB there. We'll have AB there is equal to 0.64. And then by that means that A is being multiplied by B, just like what we have here with the P and the R. So B is equal to 0.64 over A. So we don't have to spend the entire night solving a problem if we solve one that is similar to that before. We may solve by analogy. So you're going to be familiar with some of the problem-solving techniques. And I'm going to tell you some of them, just the name of them now. This is one, solved by analogy. We have means-ends analysis. We have top-down design. We have building block approach. And the opposite to building block is what? Divide and conquer, yes. Divide and conquer is the opposite. So we have a lot of different strategies that we can use in solving problems in mathematics and in life in general. So in that case, number 7, we are attempting to make f the subject of the formula. Let's see if that is what we have there. Make f the subject of the formula. Yes. Go straight ahead and make f the subject of the formula. Now, we have FLAW over 800. Surely, the 800 is the one that is least related to the proposed subject. So the 800 that we have there in the denominator is the least related to the proposed subject. So we will eliminate the 800 first. We are dividing by 800 here. Therefore, we will eliminate the 800 by multiplication. So multiplying both sides, what will happen is that the 800 will be eliminated from the left-hand side, and on the right-hand side, we have 800b. And some students would put what? B800, which is not wrong, but it is unorthodox. It is what? Apart from unorthodox, what is the other word that we may use? Unconventional. Yes, it may be unconventional. So there we go. So the next thing is that, of course, we are focusing at all times on our proposed subject, which is f in this particular case. So we will eliminate LAW. And the LAW is related to f by multiplication. Since it's related by multiplication, we will what? Eliminate the LAW by division. So we will divide both sides by LAW. What happens is that LAW will be eliminated from the right hand side, and on the left hand side we have 800D over LAW. And then finally, turn the beat around. We have what? F is equal to 800B over LAW. Notice, students, that I have never said that anything goes over the equal sign. And I have never said that anything changes sign. Why? Because it's not the right thing to do. Nothing goes over the equal sign, and nothing changes signs. So those are the two great misconceptions of transposition. That something just jump over the equal sign. That's one. And the next thing is that something changes sign. Nothing changes signs. Let's continue. Number 8. Of course, the proposed subject for this one is obvious, because surely it cannot be lowercase r, because it's already the subject, and surely it cannot be 6.3. So it must be the uppercase R that is the proposed subject. And of course, that uppercase R is accompanied by a negative 6.3. So the 6.3 is what? Subtracted from R. Because its relationship with R is subtraction, we will eliminate it by addition. Yes, we are going to eliminate it by addition. And we are going to add 6.3 on the left-hand side also. So when we add 6.3 on the right-hand side, the negative 6.3 is eliminated. And on the right-hand side, the negative 6.3 is eliminated. On the left-hand side, we have what? Plus 6.3. That's what we have. And then what is the final? We make R the subject of the formula, so we have R plus 6.3. We just turn it around. And that's all there is to it. Now, number 9, V is equal to U plus AT. V is equal to U plus AT is either for A or T, I think. So let us take a look at it. For A. Yes, for A. It's either for A or T, it is for A. Right. That's nice. I love number 9. What do we say about number 9 now? We are making A the subject of the formula. Making A the subject of the formula, we have two things to eliminate. We have the U and we have the T. And which one? So I'm looking for an answer now. I'm seeking an answer for someone. Which one do we eliminate and why? So we need to eliminate the U and we need to eliminate the T in order to make A the subject of the formula. Which one do we eliminate first and why? I imagine that I will see that in a few seconds. Alright, so I'm going to see that. We eliminate, one say that we eliminate the T first, the other says that we eliminate the U first. But don't just say that we eliminate the T or the U first. Tell why. Tell why. Why do we eliminate the one that we say that we eliminate? Which one? Why do we eliminate that one first? Alright. The rule is you eliminate the one that is least related to the proposed subject first. So that is the one that you will eliminate first. The one that is least, the one that is furthest from this side. Not the one that is furthest away from the one that is furthest away from the proposed subject. T, because it is furthest from the sign. You have to eliminate the one that is the equal sign. No, you don't eliminate. Oh, you have to eliminate not furthest away from the equal sign, furthest away from the proposed subject. Not the furthest away from the equal sign, furthest away from the proposed subject. The proposed subject is A. And when we say furthest, we don't mean physically furthest, we mean logically furthest. So that we say that the one that is least related to the proposed subject first. So we will eliminate the one that is least related to the proposed subject first. The proposed subject is A. The one that is least related to it is U. So that's the one that we eliminate first. And of course, U is in an addition-subtraction relationship. We can just say an addition relationship. It is in an addition relationship with the proposed subject. So we'll eliminate that U by subtraction. And we will subtract U from the left-hand side also. So we're going to subtract U from both sides. When we subtract U from the right-hand side, we just have AT. When we subtract u from the left hand side, we have v minus u. Then finally, what do we eliminate? Of course, there is only one thing to eliminate, which is the t. And the t is related to the proposed subject by multiplication. So we will divide both sides by t. Dividing the left hand side by t, we have v minus u over t. And dividing the right hand side by t, the t is going to be eliminated. So that what? A is equal to v minus u over t. Number 10, we will take 2 goes at number 10. 2 takes. Let's go. Why is it that A is the subject? Because the problem says so. It's just that I don't write it out on the board because that's going to take up a lot of space. The proposed subject is A. Make A the subject of the formula. That's what the problem says. Well, maybe the video is actually delayed as a matter of fact. Maybe. So let's go to this one. Number 10. Making Q the subject of the formula. I know that some students would want to eliminate the furthest one from the Q first. And the furthest one from the Q is the 17. That's fine. That's fine. So we'll say what? Since the 17 is added, we will eliminate by subtraction. So we have P minus 17 is equal to Q over 5. Then later on, we will multiply by 5. Because we are dividing by 5, we will eliminate this 5 by multiplication. We will multiply both sides by 5, and what do we have? 5 to be multiplied by all of P minus 17, and then that is equal to Q. And we finish up by saying Q is equal to 5 multiplied by all of P minus 17. Right. Some students would not want to do that. Some students will be aggressive against having any denominator at all. And you will see that in quite a few cases, it will be best to eliminate the denominator first when we can do that. All right. So, all right, so I guess we have the thing right here on the screen. My computer light showing right here. So just turn away the computer screen. It's still there. Well, I'm going to turn it away some more. Well, it's a little bit better now. All right, so yes. Okay, you're seeing it now. That's fine. Let's continue. Now, although one may want to eliminate the one that is furthest from the proposed subject first, some students, as I said before, are aggressive against denominators. And as soon as they see the denominator in the problem, they want to eliminate that. So in order to eliminate this denominator, we have to multiply the entire equation. You cannot multiply just the left-hand side by 5 or the right-hand side by 5. We'll have to... Okay, thanks. Hello. So I see someone saying, hi, Mr. James. Yes, I'm delighted to have you on this live also. Yes. Yes, I'm really delighted to have you on this live. Yeah, there's a Google Meet link, but we do not use it when TikTok is going on. Okay. The, see that link there? We don't use it. We use it when we're having difficulty with TikTok. That's the only time I use it. All right, so let us continue. Let's continue. So, as I said, some students would want to eliminate the denominator first, and we call it flattening the equation. Yes, so we cause the equation to look flat. Yes. Flattening the equation. So let us flatten the equation. When flattening the equation, we need to multiply by 5, and we need to multiply by 5 straight through. So let's begin. If we multiply p by 5, we are going to get 5p. If we multiply q over 5, if we multiply that by 5, the 5 will cancel, and that will give us q. And then when we multiply 17 by 5, we get 85. So we need to multiply everything by 5. Every term and everywhere. Then, of course, accompanying q is 85, right there, that is added. And we will eliminate that 85 that is added by subtracting 85. So we'll have what? 5p minus 85 is equal to q. So q is equal to what? 5p minus 85, which is identically equal to 5 times all of p minus 17. So this, what we have here, is identically equal to this. But it is just in another form. So only the form is different, but they are identically equal. So what do we say about that? Of course, let me show you what we mean by, let me show you how we represent that in mathematics. We represent this in mathematics like this. P minus 17 is identically equal, 3 dashes. 3 dashes. 5p minus 85. So when we say that this is identically equal to this one is a two-sided one. So if p is 5 times all of p minus 17 is identically equal to 5p minus 85, then 5p minus 8, it might be written in the other direction. It's just fine. This equal sign with the 3 dashes, it means identically equal to. And that one is a two-directional sign. So in any direction it works. But of course your regular equal sign is a one-directional sign. And you have to be careful what you put on the left-hand side and also on the right-hand side of an equal sign. Alright, so we are at the end of the next 5, and of course, you know what is going to happen. I'm going to put another 5 up there so that we can have more fun. And of course, as you go along, we should get problems that are a little bit more challenging. Let's see. Alright, so I'm going to erase those, and students keep them in mind. Because maybe, as a matter of fact, not maybe, for certain, we will do some solution by what? By analogy. Right, so for sure, we're going to do some solutions by analogy. So, keep everything together. Solution by analogy. We're going to do that. No doubt. Is there anything? I cannot find my book. Here it is. So, we will move very nicely to number 15. Alright, number 15. Let's go. Number 11. W is equal to U minus Vx. Number 12. Notice how close I am putting number 12 to it. Because I imagine that it should not be maybe I should put it just one character down. 12. Yeah. Number 12. M is equal to 3L over L minus common L. And in that case, we are making common L, the smaller case L, the subject of the formula. Number 13. That's nice. Number 13. S is equal to pi r plus h for h. And of course, if you notice, I'm taking a second take on number 13. S is equal to pi r plus h for h. So I'm taking a second take on number 13. Number 14 is just one take on number 14. And I'm happy about it. A is equal to B minus common B, or lowercase b, over 2c for capital R uppercase B. And number 15 is your favorite. Good thing, which is the last one in the set. What do we say about that one? I have enough space down here to make a meal of that problem before we continue. So we have W is equal to V. Something is wrong with that. I need to write it over. U minus Vx for x. U minus Vx for x. Students, need I say that we have said it before, and we saw that in the introductory problems that we were solving on the last occasion. So the last time we had an instructional class, which was last week Thursday. Yes. The last time we had an instructional class was last week Thursday. And last week Thursday, we saw, what did we see last week Thursday, apart from nothing? We saw that it makes a difference how we approach a problem that can be approached in quite a few different ways. Now let us take a look at that one. W is equal to u minus vx. W is equal to u minus vx for x. What is the first thing that we eliminate, and by what process do we eliminate it? So that's what I'm going to be asking. What do we eliminate first? We start at 6 p.m. on the days that we have class. So students, please, we are making x the subject of the formula. What do we eliminate first and why? We are making x, so x is the proposed subject on this occasion. What do we eliminate first and why? I'm going to give you a few seconds on that. We eliminate the u by addition. Why do we? All right. Am I freezing on the other sets? V. The person who said that we should eliminate u by addition. Why should we eliminate u by addition? Why would we eliminate? Somebody is saying u again. So one said v. What process should we use to eliminate that u? One person say addition. Anybody with a different take? Anybody with a different take to say that we should eliminate u by something other than addition? Should we eliminate u? We should eliminate u by what? By addition, by subtraction, by multiplication, by division. One person saying it's addition already. Anybody with Anybody with a different take that we should eliminate u by something else apart from addition? Okay. Does u have a negative sign? Do you see u with a negative sign there? Is he the only one who is seeing that u has a negative sign? Anybody is seeing that u, who say that u has a negative sign? Somebody saying that we should? The students are speaking in pidgin. You have to say something that in a full sentence that I can understand. Or if it is even a phrase, then I see a negative sign coming up on the screen. What does that signify? I don't know what the minus sign we are saying minus sign for. Okay, all right. So let me ask a question then. And then when you give me a plain answer, then I will understand what you are saying.
Sir,
Yes.
now sir, you would have eliminated you first, sir, with the addition, because
Right.
it is 5 on X, so it is 4 this on X.
Okay, of course, when you eliminate in your context, I will not have any difficulty with what you're saying, because you're saying that we should eliminate the u because it is furthest from the proposed subject. That's correct. But when you're saying that I should eliminate the u by addition, then there's something seriously wrong with what you're saying there now. Because you're saying that u has a negative sign. Does u have a negative sign there?
So we can after X here, so that's why we say addition. So
Repeat that?
the negative sign, the minus sign come after it, so that's why we say addition.
But you couldn't judge a sign that comes after you to be the sign of you. Because you know, because I'm not saying that you don't know, but you know, I know that you know. You know that the sign that belongs to you cannot be the one that comes after you. You know that. So why all of a
So
sudden? Repeat that?
minus, you don't put minus u, like, when I rewrite, you don't put double minus u equal.
Right. You write W minus U because you know that U does not have a sign because the sign that would be pertaining to you would be the sign that goes ahead of you or before you. So because there's no sign here, you know that U is positive. So if U is positive, then we'll say W minus U then. So we'll say W minus U. And what will go on the right hand side?
Equal Vx, cause like, you take away u as 0. Are you learn that?
Alright. So what will be on this? What will be left on the right hand side? Tell me what you just said because I wanted to repeat it,
Just Vx alone, sir.
Is that right? But that could not be right.
Alright.
Why is it that this could not be right? The right hand, this side is correct, but this side is not correct.
So you don't put take away u
Of
after
course, you
that.
have to have a negative Vx. You just eliminated the u, and you are not doing anything apart from eliminating the u. So the other thing must remain just as it is. So only the u that you are eliminating right there. So you have a negative Vx. Then what is the next step? Let's go. What's the next step? It's the same process that you have been working with. So just do the same thing, what you have been doing all along.
You don't do the same thing with the v, sir.
No, oh, here's the question. You know that the next thing that we need to eliminate is v. You can evaluate this side. What do you need to do in order to do what to eliminate what you need to eliminate in order to make x a subject? Because you have to eliminate something to make x a subject. What is it that you are going to eliminate in making x a subject? You come like you're afraid to say what you see. Like you probably think that I'm seeing something different from you. I'm seeing the same thing that you are seeing.
So you don't put, like, when I rewrite it, so when left side, so but like, you don't put plus v on the right side and you don't,
No,
I cancel
you cannot cheat the process.
x alone like on the right.
No, you cannot cheat the process. You have to just do the same thing that you would normally do under this circumstance.
So when I rewrite it on the left side, you don't put, like,
But why would you rewrite
v
it on
double.
the left side immediately without
No, like,
eliminating what you need to eliminate? I'm going to look. Somebody is saying that I will have to divide. Nice. We'll have to divide because we have something related to the proposed subject and it is being multiplied by the proposed subject. What Vx mean? It means that it's being multiplied. So, but you have to tell me what you're going to divide by. What are you going to divide by? This one
So then put W take away U.
We have W take away U, which is on the left hand side. It is not interfering with the proposed subject that is over here. So it's the one that is interfering with the proposed subject that you need to eliminate. Somebody is saying that I should divide. In mathematics, you not just divide. In mathematics, you have to divide by something.
Divided by negative V.
Divide by negative V. Because you need to eliminate not just the V, but also the negative sign that accompanies it. So you need to eliminate the entire thing.
You respect what I would.
Right. So you do that, you're going to divide by negative V. So you're going to have W, you're going to have W minus U over negative V is equal to X. And of course what you're going to have is what? X is equal to W minus U over negative V. And if you do that in an examination in which you are required to write out your answer like that, if the problem values 15 marks, you will get all 15 marks. You will get all of your 15 marks for that. However, if you are doing a multiple choice problem, you will not see this among the options. Why is it that you will not see this among the options? If you're doing a multiple choice problem, you're not going to see that among the options. Why? If no one can say why, I'm going to say why. And you...
Yes, sir.
Yes?
When you say multiple choice, repeat that, sir.
All right. If you're doing a multiple choice problem, you're not going to see this as one of the options. Although it is correct.
Sir, if you go to see answer alone.
Why is it? Repeat that.
You go see answer by itself, you're not going to see like a small word, like you see the answer.
But you're not going to see this. You'll not see this. You'll not see this as in any other options. I'm sure that I've told you why you would not see that. And when I'm going to say it again. There are two reasons here why you would not see that as in the options. I'm looking in the chat to see if there's anybody who's going to tell me why I would not see this. Although it is correct, in a multiple choice, you will not see that as one of the answers. Two reasons. What are the two reasons? Or what? Give me anyone. Anyone is fine. Two reasons. I'm going to give you two reasons. One, you will not see an answer given with a negative denominator. So that's the first one. You will not see an answer given with a negative denominator. Two, we have 1, 2, 3 terms. And among the 3 terms, 2 of them have negative sign. You will not see the terms, the negative terms, outnumbering the positive terms in a fraction. In a fraction. If it is a flat expression, maybe, but not in a fraction. So there are your two reasons. One, you will not see an answer written with a negative denominator, and two, the negative signs will not, in a fraction, will not outnumber the positive signs. Therefore, you'll have to go all the way around and around and around to get the correct answer. Because, well, this is a correct answer, but the one that they want to see is this one, where you multiply both numerator and denominator by a negative quantity. So you multiply this a negative u by a negative 1, you'll get u. Multiply w by a negative 1, you'll get negative w. And multiply negative v by a negative 1, you'll get a positive v. So that's what you're going to see. That is the one that you're going to see. You're going to see x is equal to u minus w over v. That is what you're going to see for the answer. Now, the reason why I've taken it this far to explain it is because we can see students in life is the same thing, you know. It's the same thing in life. Where you should try to make projections. So, you are going to try to open a business. You're going to make a projection to say that I will earn this, or this is going to be my overheads and so on. So you know if it is going to be lucrative or not. You don't just jump in it and say, I see other people make money, so I'm going to do it. You'd have to weigh it out. And it's the same thing with the problem that you're solving here. See how much we have gone through in just solving this problem? Look at this now and tell me if it's the same problem. Look at it now. I'm solving a problem in which I'm going to transpose a formula to make x the subject of the formula. Now, x is on the right-hand side, which, of course, still makes the problem a regulation problem. But in addition to that, the proposed subject is present in a negative term. And if you allow the proposed subject to remain in a negative term, then you will have to divide by a negative quantity. So you have to see students and you have to evaluate the circumstance. And then when you evaluate the circumstance, then you proceed in the most efficient way. The proposed subject being on the right-hand side is not as bad as the proposed subject present in a negative term. So as soon as I see that the proposed subject is in a negative term, I am going to take steps to make sure that it is present in a positive term. So instead of subtracting the u, I will add the negative vx. So I will eliminate this negative vx by adding vx. So I will have a vx here is equal to u. Why I do that? Because I am not going to keep the w on the left-hand side. I am also going to eliminate this w from the left-hand side. And this w, not having a sign, you know that it is positive. So we'll eliminate the w by subtracting w. And we'll do that and we subtract w on both sides. So we'll eliminate this negative vx so that we can get the proposed subject to be in a positive term. And in the same breath, we'll eliminate the w because we'll eventually have to do it because it's going to be on the same side with the proposed subject, so we may as well eliminate it right away. Finally, we need to eliminate the v. Of course, by now, the v is positive. The x is in a positive term. So all that we need to do is divide by v on both sides. So x is equal to u minus w over v. Now look at what we have gone through, students, all because we did not evaluate the problem early to see that the proposed subject is in a negative term, and then the best thing to do would be to get it in a positive term. And that is why I've taken it on this side, because I surely would not want to cause that to be the, what I would say, the approach that I take to the problem. Nice. So we have done that in 2 steps, whereas this seems to be what? One of those never-ending stories. Right. So we have done something like this before. It's just that you are not remembering. Well, then you better remember by the time I finish with number 15. Although I've not written it on the board as yet. Let's go down to number 12. Number 12, we are making this minor case or lowercase l the proposed subject. That's the lowercase l, and that is the proposed subject. So in that case, the proposed subject is the lowercase l. Now students, we are making the lowercase l the subject of the formula. What is the proposed first step that we should take? The proposed first step. What would you propose for the first step? We are making this lowercase l the subject of the formula. What is your proposed first step? What is your first step?
This all look funny, sir.
Repeat that?
Funny look kind of confused. One that was supposed to say 3L and then I saw L, so we'll have to do it that one.
Alright. You know why I would not be disturbed by that? I would not be disturbed by that because of the presence of the 3L and the L, that these are occurrences of the same thing. I wouldn't be too bothered by it. The reason being, well, you're eventually going to give it some consideration. But now, we don't have to give it much consideration because it is not the proposed subject. So because it is not the proposed subject, I wouldn't give it consideration. And of course, yes, go ahead. Let me hear what you have to say.
You would have to get rid of 3L, sir.
You would probably want to do that and then do the reciprocal, and then of course we'll make a lovely meal of the problem. But I think that from here on, the easiest approach would be to eliminate the denominator, to flatten the equation, so that we have a flat expression rather than one that contains fractions. Eventually, the answer will be in a fractional form. But during the process, if we can avoid working with fractions, then that would be the best thing to do. So if we eliminate this fraction, if we eliminate this denominator, of course, a denominator is something that we are dividing by. So we'll eliminate this denominator by multiplying by the denominator. And we'll do that on both sides. So if we multiply by L minus L on the right hand side, all that we'll have is this 3L. And if we multiply by that, on the left hand side, we'll have M to be multiplied by L minus L. That's what we'll have. So we have eliminated the L minus L from the right hand side, and then that is what we have on the left hand side. Now, can anybody propose something to do now? What do you imagine that I will do in this case? Next step. What would be your next step?
Sir,
Yes?
if I lowercase I subject, sir, did it end up on the right hand side again, so you can make me laugh.
You don't see that all that we are doing is eliminating this denominator.
So, a while ago, you take out you want either for yourself, or like, I mean, cancel. Like, you're so tricky. And that's the one I was saying.
No, I multiply. Let me put that under the microscope. I'm looking, okay, I can put it right here in the meantime. Alright. We have M is equal to 3L over L minus L. What I've done is I multiply by L minus L right there. And multiply by L minus L right there. This will have to be in brackets. Also this in brackets. So I multiply both sides by L minus L. In that way, the L minus L is eliminated from the left hand side. Sorry, from the right hand side. And this is what we have. And then on the left hand side, that is what we have. Is that difficult to see? Still?
We see it, sir.
Okay. Next thing that we do now, what do you suggest that we will do next? Because this little L is the proposed subject. What do you suggest that we do? The next thing that I will do, because it is inside of this brackets, I will expand the brackets so that the proposed subject is no longer in the brackets. So what I do is ML minus ML. So we expand the bracket. So we multiply the M by the uppercase L, we multiply the M by the lowercase l by the distributive law. Is that okay? Is that okay?
Correct. Yeah, we see it, sir.
Alright.
So,
the next thing that I'm going to do is what? Tell me what you think that I will do.
Divide by M. That's short.
If you divide by M, of course, that is a good portion of the elimination process. That's fine. It can be done. But it would not get us to the answer in the most efficient way. See what we have just done a while ago? Notice that the proposed subject is in a negative term. Do you see that? That the proposed subject is in a negative term. Do you see that? Yes? No? The proposed subject is in a negative term.
So, sorry. You don't cancel the ML with the capital one, the first one. So you have the next one alone by itself.
No, what I will do, because by doing this cancellation and division, you run yourself in the problem of getting fractions again, which is what you're avoiding. You're going to eventually have to use a fraction, but don't put it in the middle of the process unnecessarily. So in this particular case, because the proposed subject is in a negative term, I will eliminate it from this side. Remember, that's what we did here. The proposed subject is in a negative term here. Well,
so you don't just like divide it by a negative M alone, sir. And it'll go left. Like, you don't divide it by M, like negative M alone. It'll go left by itself for that.
Eventually. Yes, we'll do that eventually. But you wouldn't want to make that step now. Because that is going to cause the entire process to be difficult. It's going to be too harsh. So what I would do is, this is what I'll do. I'll take the ML, eliminate this 3L from the right hand side, and negative 3L. Eliminate this negative ML from this side, I get a positive ML, because the proposed subject, we intend to get it in a positive term. Now, see, now that you're ready to eliminate the M by division, it will not cause so much problem. Because you intend to divide by M. When you divide by M, the entire thing is going to look horrible, to say the least. So if you could single out the term ML by itself and then divide by the M, then that would be a better take. But eventually you'll have to divide by the M as you suggest. But I think that you're dividing by the m too quickly. So now, if you divide by m, the problem is over. But it's the same situation that we had here, where we have the proposed subject present in a negative term. So we eliminate it from this side. The side on which it is present in the negative term, we eliminate it from that side. And it occurs, therefore, on the other side in a positive term, like this. And then what do we do? The same thing that you have been telling me a few minutes ago that we should do, which is divide by m. So we divide by m now. So ml minus 3l over m is equal to L. So L is equal to ml minus 3l over m, which is what you said that we should do. But you're just doing it too quickly. You are neglecting quite a few things there, especially that the proposed subject was in a negative term. Right, so your proposed subject was in a negative term right there. All right, so what do we do next? Go here. We notice that I've written the number 13 twice. So one suggestion is that H is the proposed subject. Since H is the proposed subject, one that is furthest away from the proposed subject is pi r. So since pi r is furthest away from the proposed subject, we would divide by pi r, and then that is equal to r plus h. And then what may we do next? Because what have we done? We've eliminated the pi r, which is furthest away from the proposed subject. We have done that. So the only thing that is left is that r. And how do we eliminate that r? We will eliminate that r by subtraction. So we have s over pi r minus r is equal to h. So h is equal to s over pi r minus r. And we are done. The other suggestion is that we could expand the brackets, because the proposed subject is inside of these brackets. So one suggestion would be to expand the brackets. And notice that what you suggested is something similar to this. You suggested here is something similar to this. But let's continue with this. We will expand the bracket. So S is equal to pi r times r, which will give us pi r squared. And then we'll have what? Pi r times h, we'll have pi r h. And of course, since we have been solving problems earlier on, you know exactly what to do with this. To eliminate the pi r squared. So what do you say? S minus pi r squared is equal to pi r h. And finally, you will eliminate, because you have just eliminated the pi r squared by subtraction, you will eliminate the pi r by dividing by pi r. So you'll have s minus pi r squared over pi r is equal to h. And then you write, finish by saying s minus pi r squared over pi r. Now we have two takes. Look at this. This and this. Which one would you see in a multiple choice option? And which one would be a better approach to the solution of the problem? Surely this one. for two reasons. One, mathematicians prefer to have a single fraction rather than a mixed expression. So the mathematicians would want to write a single fraction rather than a mixed expression, like we have it there. So you write a single fraction. The other one is that some students, while subtracting the r here, might make a mistake and do this, s over pi r. And instead of subtracting the r all the way over there, they put it in the numerator there, which would be disastrous. So this is another reason for not preferring this one, because it is subject to error, and also it is better to write a single fraction rather than a mixed expression. Now, number 14, you will not have any difficulty with number 14. You will just move through it easily. So let me ask the question generally to the class. We are making uppercase B the subject of the formula. What do we eliminate first? We are making uppercase B the subject of the formula. What do we eliminate first? No response? We are making uppercase B the subject of the formula. What do we eliminate first? 2c. Exactly. We are dividing by 2c, we multiply by 2c. So we'll have what? Not 2ca, but 2ac is equal to b minus b. And what do we eliminate next? There's only one thing left to be eliminated, and it's this lowercase b, and it is related to that by subtraction. So we'll eliminate it by addition. 2ac plus b is equal to b. So b is equal to 2ac plus b. And we are done. Number 15. M is equal to 3l over L minus L. The same problem that we have there for number 12, but on this occasion, we are making the uppercase L the subject of the formula, and we will attempt to solve it by analogy. Solve by analogy. Of course, the problem, you can see that there's a resemblance and there's some relationship because it's the exact same expression. But where does the similarity discontinue? So, of course, because of the same expression, we know that the problem is similar. But the similarity might discontinue even for the first step. But maybe it is not just for the first step alone, so we can see that we might be able to use some of the steps that we have there. So let's go. Now, we are making uppercase L the subject of the formula. Solve by analogy. May we use this step as it is? Yes or no? May we use that step as it is? Anyone to answer? I'm looking. No one answering as yet. We are, in this case, we made lowercase l the subject of the formula. In this case, we are making uppercase L the subject of the formula. My question to you is, may we use the first step that we have here over here also? Yes, of course, we may use it, so let us use it. Now, students, I'm using the same step, but I'm not including this part. I'm going to write the expanded form, because we are going to multiply and then we are going to wait another 3 years before we expand. So let us multiply and expand right away. So we're going to multiply right away. So we're going to say what? M times L is M capital L. Then M times lowercase minus M times lowercase l. And that is equal to 3L. Nice. We are making the uppercase L the subject of the formula. Right? May we do this step also? Yes or no? May we do that step also? If we are making the uppercase L the subject of the formula, may we do this step also? Yes or no? Yes, of course, because if we are making the uppercase L the subject of the formula, this step just places what? The uppercase, all occurrences of the uppercase L on the left hand side and everything else on the right hand side. So this is a perfect step right there. So we may include that step just as it is. What? ML minus 3L is equal to what? M lowercase l. Students, what do we do now? We have all the occurrences of the uppercase L, which is the proposed subject, on the left hand side. What do we do next? Of course, we have solved problems like this on the previous occasion. What do we do? Speak up right now, because you know what to do, because we have done that before. Let's go. What do we do from here on? Because the analogy, I think that the analogy ends there. So what do? We have all occurrences of the proposed subject on the same side and everything else on the other side. What do we usually do? Because we have done that before. No answer as yet. We factorize L. M minus 3 is equal to ML. And then finally, what is L equal to? Finally, what is L equal to? Of course, L preceding the brackets here, meaning that we are multiplying. So since we are multiplying, what do? We will eliminate the m minus 3 by division. They are related by multiplication. Eliminate the m minus 3 by division. So we have m L over m minus 3. And that's it. So that is solving by analogy, where the first few steps may be used as they are, and then the analogy ends. So exactly we divide by m minus 3. Alright. So for the class exercise, we have what? One set left. For the class exercise, we have one set of 5 left. What do we say? One set of 5 left. One set of 5 remaining for your class exercise. Yeah, number 16 is your favorite? It should not be written like that. The sign should cater for the G. Right. Number 17, I think I'll put it about there. Beautiful. $18, $19, and $20. I think that what I like in this section, I don't see any that I would want to work out 2 times. Alright, if it's any problem, I put it lower. Nice. And then number 20. Notice that I'm writing each one only once. Number 16 and 17 should be pretty much regulation. There's nothing hard about number 18, even 19. Don't be disturbed by number 20. Let's go. Nice. Let's go. We are attempting to make H the subject of the formula. What do we eliminate first? I'm inviting the students so that they can say something. What do we eliminate first? Number 16, we are attempting to make H the subject of the formula. What do we eliminate first? V. Yes, we are attempting. We are attempting to make H the subject of the formula. What do we eliminate first? Well, someone saying that they can't see the invite. No problem. Two G I think that the students are having some difficulties. I think that everyone needs glasses. Not only that, but no one here was present when I did the first class on transposition of family. All right, so let's go. Someone is saying that we should eliminate the V. How would you eliminate the V if you want to make H the subject of the formula when the V is not on the same side as the H? Yes, the V. The V is not on the same side as the H. The other person is saying that we should eliminate the 2G. What would be the difficulty eliminating it as the first thing to eliminate 2G first? You don't see any difficulty there eliminating the 2G first? All right. Well, since I'm the only one with spectacles, I see the square root sign that we need to eliminate, and we're going to eliminate it by squaring both sides. So V squared is equal to 2GH. Then I will eliminate the 2G. V squared over 2G is equal to H, so H is equal to V squared over 2G. That's it. I would eliminate the square root sign first. I move down to the next one. T is equal to 2 pi square root of L over G. What do I eliminate first? What do I eliminate first in that case? No answer. Well, I'll eliminate the 2 pi first. So we'll have what? T over 2 pi is equal to the square root of L over G. And this problem is closely analogous to one of the problems that we solved in the first class. So I've eliminated the 2 pi. The next thing that I will eliminate is the square root sign, as someone suggests. But I would eliminate the 2 pi before I eliminate the square root. So eliminate the square root by squaring, just like we did in the exercise last week, Thursday, 4 pi squared. And if we are making L the subject of the formula, which we are doing on this occasion, we will eliminate the G next. The G is the next thing that we eliminate, and we will eliminate that G that we are dividing by multiplying by G. So T squared G over 4 pi squared is equal to L. So finally, L is equal to T squared G over 4 pi squared. This one, we solve a problem that is similar to this one. Number 17, I think. It was number 17? No. Is it number 10? Maybe it's number 10. Where we eliminated the denominator. So we're going to multiply by r on both sides. So we'll have PR minus MGR is equal to MV squared. And of course, M is our proposed subject. M on this occasion is our proposed subject. So what I'll do is we'll take the necessary step to get all of the terms that contain M on one side, preferably the left-hand side. However, if we go for the left-hand side, all of the terms will be negative. So to go for all positive terms, we will accumulate all of the terms that contain M on the right-hand side. And then we'll do what we normally do, which is what? PR. When we have all of the terms that contain the proposed subject, we factorize. Taking a common factor of M, we have V squared plus MGR. And what do we do next? In every case that we factorize, the next step is generally to divide by the large factor. So let us divide by the large factor. Dividing by the large factor, we have PR over V squared plus GR is equal to M. M is therefore equal to PR over V squared plus GR. And what do we say next? Number 19, x is equal to p plus over p plus 1. Number 19, x is equal to p plus 2 over p plus 1. And what do we do with that one? The first thing that we do is eliminate the denominator by multiplying by p plus 1. And of course, that we're going to do on both sides. So multiply by p plus 1, what do we get? The x will multiply by the p, so we get px. Then the x is going to multiply by the 1. So 1 times x is just x. P is our proposed subject. We should have all of the terms that contain p on one side. So px is here. This p will be eliminated from this side by subtracting p. And of course, in the same step, we will eliminate the positive x from this side by subtracting x on both sides. And if we are making p the subject of the formula, then we have two occurrences of p. It is the same thing all over again. We need to factorize, take out a common factor of p. So x minus 1 is equal to 2 minus x. And then we finish up by dividing p is equal to 2 minus x over x minus 1. For the most part, as a matter of fact, I think that the problems that we chose for the demonstration last week, Thursday, was an excellent set of problems because at the moment you can see what's happening. Most of what we have done today would have been catered for in terms of the approach that we are taking in the exercises that we did last week, Thursday. And then this is our final problem, number 20. And what do we say? What do we eliminate first? Right, so what would we eliminate first? Alright, so let's finish up. We will eliminate the 2k first. We are attempting to make x the subject of the formula. Our proposed subject is x. Yes, we are seeing that there's a delay, and some say it is bad. Well, you should see the one that is on YouTube. This delay that we have is not so horrible, as a matter of fact. Alright, so let's continue. We will eliminate the 2k first. So v squared over 2k is equal to 1 over x minus 1 over a. Right. So what the examiners are doing here, they are testing your flexibility in transposing an equation or transposing a formula. And of course, as soon as you see the 1 over x, if you reciprocate the 1 over x, you're going to get x. And that is what you want. So students will be overly anxious to do the reciprocal, and as a result of that, they will make that step too early. So what I'm going to do, I'm not going to make that step too early, because what I've done first is eliminate the 2k. And I'm still not going to reciprocate yet. What I will do, I'll also eliminate the 1 over a. So we have what? We are subtracting this 1 over a. We will eliminate it by addition. So we'll have v squared over 2k is plus 1 over a is equal to 1 over x. And everybody is saying, yeah, now that we have gotten to this point, it is reciprocating time. Yes, everyone wants to say yes, reciprocating time. You say yes, but I say no. We do not do the reciprocal as yet. Right, what do I do? For you to reciprocate both sides, you will have to have only 2 fractions. In order to do the reciprocal, you need to have what? Only 2 fractions, 1 on either side. Presently, we have 2 fractions on the left-hand side, so we cannot reciprocate. So what do we do first? We convert this side to a single fraction by taking a common denominator. Something that the 2k can divide into, and something that the a will divide into also. So when we divide 2k into 2ka, the 2k will cancel and the a will be left to multiply the b squared. See, this cancel this and the a is left to multiply the b squared. ab squared plus. Here, the a will cancel the a and we'll have the 2k to multiply by 1, which is giving you 2k. And then that is equal to 1 over x. Now, you may go straight ahead and reciprocate. Put it in alphabetical order. This is what we have. Over ab squared plus 2k is equal to x, because when we reciprocate 1 over x, we have x. But the examiners expect that we will want to do the reciprocal, and some students will take what? That step a long time before it is due. Right, so the students will make this step ages before the step is due. And making the step ages before it is due, that is what will cause them to make a meal of the entire problem. Now, students, we have just a few seconds remaining. What I will do is attempt to demonstrate some of the mathematics resources. Just a few minutes. This is tutorial 1. Paper 2 solution. Another instructional manual. And more instructional manual. I will let that remain. Okay. Now for the students who do not know anything about the mathematics resources, we use resources in this class, and you all will find the resources most useful the closer you get to the examination. Now for those students who have neglected the resources, you're going to neglect the resources to your own peril. Because when it gets closer to the examination, then that is when you are going to move to the mathematics resources for sure. Unless you don't want to pass, or it doesn't matter, then you will not consider the mathematics resources. Now, the mathematics resources consists of instructional manuals. So we are going to show you just a few of the instructional manuals for those who do not know them. We have vectors, matrices, and transformation. Right, vectors, matrices, and transformation is the one that we have right here. Then, of course, we have functions part 2, because we work heavily with functions. This is the second part of functions. So we have the instructional manuals. These are the instructional manuals. This one is computations part 1. Computations part 2 is over there. I don't think it is here. No, it is not. And we have the trigonometry, and of course, the great one, algebra. So we have all of your instructional manuals. They are not, this is not all of them. I think that we just only have 5. 1, 2, 3, 4, 5. There are 7 of them. There are 7 instructional manuals. The tutorials, we have 2 tutorials. We have tutorial 1 and tutorial 2. We are just picking up tutorial 1 right here. So when you're, this, right. So when you're practicing after class, apart from that, you have your homework exercises in your instructional manual. You have a lot of other problems to practice, and these are present in your tutorials. At another convenient time, I will present more of the instructional manuals to you. This is a final examination preparation resource book. It contains 10 full examinations. The solution and all of the solutions are handwritten. All of the diagrams are drawn, showing you what to do. So, students who insist on not having the mathematics resources early, then let me see what you'll do when you have them late. But these are designed to cause you to do well in the examinations. So you may as well make use of them or take advantage of them very early. At another time, I will demonstrate the resources when we have, maybe when we have another instructional class, maybe Monday, because I don't think that Monday we are going to be in so much of a cramped situation. So we'll take a look at that and those on Monday. So Monday will be for your instructional manuals, your tutorials, and your final examination preparation resources. And when you get closer to the examination, then you will see. Oh, thank you very much. Yes, yes. Thank you for the compliment concerning how well I write in the resources. And of course, tutorial 1 is my worst handwritten book, but algebra is probably the best handwritten. Algebra is not a handwritten book, but the solution part of the book is handwritten. Yes. Thank you very much for the compliment. And students, make sure that you get your mathematics resources early. It might look like it's a joke thing because I'm just jolly when I'm saying it, right? But I know what will happen to you if you don't have them and you do not have them early. All right, so thank you all for being a part of this class. Thank you all for inviting others, for commenting, for otherwise participating, for sharing the live, for following Richard J's mathematics resources. Thank you for every single thing. And when you see the hands go up, then you know that's the end of the class. So it is going to be, have a good night, and of course, see you all on Sunday.